Now. All right. So, good morning, good afternoon, good evening, everyone, wherever you're joining us from. Either you're joining us from Twitch, from YouTube, or via LinkedIn. Please do well to drop a message for those of us here on this joining either via YouTube or on Twitch or on LinkedIn. Please do well to drop a message on the cloud computing track so we have more persons joining us because we already have our instructor here. So yeah, we'll just wait a bit for others to join before I do the introduction and Mike, you can start. So we'll just hold on for just a few seconds before we
Yeah, take your
kickstart
time.
today's
Don't worry.
class.
Thank you, everyone,
All
for
right.
joining.
Yeah, thank you. All right. So I think I'll just drop a message on our Discord community so we'll have more persons joining us. All right. Okay, so for those of us on this call, I think some persons just joined, just few persons basically. Please do well to drop a message on the Discord room so we'll have more persons joining. So welcome Oma Umi and every other person on this call. Please do well to drop a message on the Discord room on the cloud computing track so we'll have more persons joining us because our instructor is already here. Okay, so I'll just do the introduction before you start. I think we're against time already. We're about 2 minutes into the time. All right, so yeah, welcome once again, everyone. Either you're joining from YouTube, from Twitch, or via LinkedIn. Please do well to share the link with your contact so that they'll be able to join us and they'll be able to learn. Okay, so we have Mike from Japan. He's an AI and cloud engineer and he's going to be taking us on introduction to Python programming. So yeah, welcome, Mike. Welcome once again. So yeah, you can start. You can start. Thank you so much.
Well, thank you so much, Top Universe and Ella, for inviting me. So today I will talk about Python programming. But what I thought, rather than just giving you an introduction to Python, which might be very, very boring and is something that you might find on the internet everywhere, I wanted to do something a little more advanced. So I would like to talk about Python, but in the scope of cloud computing. So at the beginning of my presentation, I will give you some general overview of Python on why would you choose this over all different languages and what does it mean to choose a computer languages. And then on regularly, progressively, I would just add some notion to how Python basically interacts with the cloud. How can you use that language at your advantage to basically create pipelines, start processing, and specifically, what are the libraries that you are likely going to find when you have to use Python with AWS. So a little bit about myself. My name is Michelangelo. I started my career in AI a few years ago when I was hired by Ernst and Young, and then I switched to a couple of companies. One startup in Australia, and where I specialize in natural language processing. And then after that, I decided to open my own consulting company in Tokyo. At the moment, I am in Italy rather than Tokyo, and I will soon move to Hong Kong. I keep traveling, but the AI world doesn't stop. So thank you for joining today. So first of all, I would like to talk about essentially what is a computer language, because especially in school, in programming in school, the first thing you start doing is basically have you hopefully hands-on with a computer language. Now, this is my understanding of computer language. A computer language corresponds to a certain technology. So, before, for example, no, before actually, right now, for example, if you choose JavaScript, you're going to do web development, you're going to do front end mostly. JavaScript is used a lot, so you can do a lot more things, but ideally, you're going to do front end. If you choose Python, Python started as a language for machine learning and automations, cloud, you know, heavy things, heavy computational things, mostly because it has several libraries for linear algebra. And then if you choose, for example, C++, C Sharp, there are other category of language. Those are languages adopted to make software. For example, Unreal Engine, which is a very famous game software, uses C++, or like its own library merged with C++. C Sharp is used by Unity. So if you want to develop this kind of software, then you have to choose this language. And very differently, if you use if you want to use blockchain, essentially Web3, you are going to create smart contracts, and that requires another language which is called Solidity. So the choice of the language, basically, it allows you to have a completely different career path. So it's up to you to choose it. Now, I think one of the biggest mistakes that people do, that students do when they start programming, it's mostly because of the school, is they are exposed to a different number of computer languages. And so basically you hear the students learning 4 or 5 languages. My suggestion is just focus on one, because the thing is, just learning the syntax of the language doesn't give you any knowledge on the language itself. That's just the basics, but the core of the languages are the libraries. Look at Python, for example. In Python, you have to know pandas, which is a library for data manipulation. If you do machine learning, you have to know sklearn, keras, TensorFlow, perhaps. And then you have to know Boto3 for the cloud. And so there are so many libraries that basically makes 95% of the language compared to the syntax. The syntax is just the start. So my suggestion is only choose one language to define your career path, because of course you want to be specific rather than being a generalist. Now, Python, why it's easier than other languages? Now, first of all, because since the last 6 months, we have ChatGPT and similar language LLM. And that makes it much easier to study computer languages than pre-GPT era, where when I studied. Python has a huge community, which means you can almost find the solution to any problem, any library you can think of. If you think about R, for example, I heard a couple of my friends saying when they were studying, R still have a big community, but when you have a problem, when you have to debug a problem, languages that are not very used do not have huge communities. So it's very difficult to find a solution to already existing problems. Python does not have that issue. Python is so used that you can find a solution to everything. So there is sufficient documentation to get you out of trouble when you need. Python is also dynamically typed. What does it mean? That in other languages you need to undergo the tedious requirement of specifying the variable type. And in Python, instead, this is free, basically. You do not have to specify the type, and that makes it much easier for beginners to just write some code. At the same time, it's strongly typed, means to have some strict rules. And so I think there are people who like it and people who do not. I personally like it, for example, when you have to take care of indentation, because that's a strict rule makes it much easier to structure some code. In JavaScript, for example, you can use the brackets wherever you want, and that can give some trouble, let's say, when you have to debug some code. Now, I'm going to talk about something specifically related to the content of the Python language, which many people will not agree to. This is on my personal experience. So when somebody is starting a computer language, if you're especially starting right now to learn a computer language, the assumption made people that they have to learn all the language to use it. My assumption is different, and which means that what I outline here is basically the frequency of use of some of the main concepts that you find in programming, specifically in Python. These, like, there are of course other things, other libraries, but in terms of syntax, I think we could summarize Python in here. All you need essentially here to program. But where I put the black text basically indicates the content that does not have a lot of frequency. And I think in reality, when you study a computer language, you only need to learn about 20-30% to do 80% of the stuff. At the beginning, of course, when you become an expert, then you expand your expertise. But at the beginning, you do not need to know, for example, inheritance or decorators, because they are not used very frequently. And so here, for example, I outline some of the things that you absolutely need, other things that you might need only a few times. For example, if you think about variables, there are global variables, even constant, but all you ever use are essentially variables in variable scope. In data structure, list and dictionary make almost 90, I would say 90% of all the data structure you find. And you can also find sets. But of course, when you're a beginner, you want to minimize the amount of complexity. You do not want to go too deep. You want to just code because you can code. And so I suggest to start with the white concept that I outlined, and then later on to study something else, in the black ones. Instead of the statements, I use if, for example, if elif for cycle. You can find them everywhere, except try. You can find it in debugging, but with us, for example, you can only find it when you have to save files. And honestly, like, you do not start to interact with JSON text for the first few months. Same as functions, for example, you can use an unlimited amount of arguments, and it's called args with double star. You only find it very, very seldomly. And the same for objects specifically, because object-oriented programming is something which is very big in Python. That's the entire structure of Python. I think, when you know how to create an object, you to instantiate the object. That's very, very important. But you do not need to use, at least at the beginning, decorators or specifically inheritance. Because I think, many people focus a lot to study inheritance, and then unless you are building a library, inheritance is almost never used in normal use cases. The other fact, the additional paradigm we have to talk when we talk about Python is called object-oriented programming. And that is basically, that's how Python it's built on. It's you have a piece of code, and you can replicate you can replicate this piece of code. This is called instantiation in different fashion. This is very useful when you do machine learning, because when you do machine learning, you take a library, you essentially load an algorithm, and then you say, okay, create different variation of this algorithm and run it. That's essentially how sklearn works. And object-oriented programming right now is becoming the norm on many computer languages, because it allows to basically store states in a very, very easy way, and store different variation in an easy way. So I think, that is the thing that you need to focus when you're studying Python. Now, what another suggestion that I would give you is, well, how do you structure your roadmap to Python? Because, the thing is, like, when there are multiple things that you need to take care of. The first, you need to just know how to code. Then you have to learn how to install libraries and dependencies. Then you have to learn how to use repository in Git. And at that point, you learn how to use different libraries and modules, etc., etc. So what I'm saying, do not do everything in one go. Just at the beginning, you can focus on the syntax. So the first thing I would say is, in the first 6 months, you can choose an online compiler, not compiler, so an online IDE or notebook. And the reason why is because, coding offline, coding on local, and setting everything up on local is much more difficult. It has its own perks, and is required at the end when you create projects. But when you just run code, there is no point of having your Visual Studio Code and IDE. So I would suggest you try to code online for the first 6 months. And Google Colab, specifically a notebook, not a Python file, notebook is perfect for that, because you just need to exercise your code. But after 6 months, when you get more experience, then you can switch and actually you can download an IDE, because the setting up usually is hellish. When you download, for example, my favorite is Visual Studio Code. When you download it, you have to download other things. Many things do not work. You have to debug it, and after that, you need to install Python in a particular way. And but the reason why you choose to work on local eventually is because you have access basically to Git repository, so you can have access to a different like a bigger amount of code, and you can start doing projects. And essentially, at the end, the objective is to deploy those projects. So if you wanted to put something on the cloud, you do not have to drag and save your file. Ideally, if you know how to do it, from your IDE, you click a button and everything goes online. That's basically the end goal of an IDE, apart from programming itself. And I think that's basically where you want to go, but not immediately, because if you start programming directly with Visual Studio Code, I think there are going to be too many issues that just makes you miserable the first few days. Because I said you have to install it, but then you have to create the notebooks, and the notebooks do not work, etc., etc. Now, which IDE should you not choose? There are two IDEs specifically that seems very attractive, but I would never recommend. Is the Visual Studio, the complete version, and Sublime. The reason why Sublime is not even considered an IDE for what I know. I haven't been updating for quite a long time, but Sublime is basically, it doesn't have all the configuration of an IDE. Visual Studio, on the other hand, the complete version is used for big projects. And what happens if you create one, you just include several other libraries you do not want, which does not make your code basically plain. It's you much want to start a project from scratch. So Visual Studio Code or Eclipse or PyCharm are very good choices to start after your 6 months. Now there is a new concept which is called Google IDX, and right now I think they are starting to integrate AI with some online IDE. So we'll see where the technology is going. So I think that's sufficient knowledge about Python. I would like instead to talk a little bit more about how Python is used in the cloud, because that I think that is more interesting, because all the information I gave you some tips, but essentially you can find them on Google. There is nothing very interesting about that. So specifically on cloud computing, I'll just make a quick introduction. Cloud is a collection of services. Is where you find database, you find simulated computer, virtual machines, computing power, where you find storage, where you find the places to create API, security. Every individual services runs basically on this huge cloud. And I'm an expert for AWS. And in order to give instruction to those services to interact those services, basically you have three choices. You can either do that manually. So there is it's called a console. So you can log in AWS and click on different buttons, and this is good if you want to do things manually. But then when you need to do things in a more complex, more refined way, and specifically in a more automatic way, you cannot do things by clicking manually. If you want an algorithm that runs once an hour, you cannot just log every once an hour and click on a button. You have to do things automatically. That's where coding comes into play. So the other thing you can do is use a CLI. It is basically command line interface. So it's like the black screen where you type code. Or you can use a Python library, which is called Boto3. And Boto3 is basically, it's a way to interact with one of the services. So for example, here I ask with the code to create a DynamoDB table, which is a database. So with this code I have on the left, that is called Boto3 in Python, I can easily create a new database, a new database table, no SQL. And that's how Boto3 works. And when I have to create my own software and I have to basically retrieve data from a database or something that I use essentially Boto3. And it's a very, very easy way to interact with the cloud because with cloud computing, Boto3 takes control of the entire AWS. And that's essentially the advantage of having a cloud over individual software, because essentially the point of having a cloud is that it costs more than individual software, but everything is integrated. So, for example, there are subsidiaries for those kind of for those services. For example, each software, you can find a better software online, but the issue with all this software, those scattered for AWS, everything is there. Instead, all the other software, they offer individual, even better solution, like MongoDB is better than DynamoDB, definitely. But is every single time, you cannot control everything at once. With the cloud, specifically with a library like Boto3, you can control everything at once. It's much more comfortable. So now I would like to talk about cloud use cases. And because I thought, okay, so among all the services, you might want to learn each one individually, and of course, that is uh, that is the entire purpose of learning the cloud. But when you talk about especially Python or your first year into the cloud, I think there are services that are way more important than the other. And there are a bunch of services that where you can perform essentially automation. So I would say the one that I outlined here, and then I would also tell the services, I would say are the services where you mostly have to use Python. All the other, for example, for database, SQL, you do not have to use Python, ETL as well, S3. But this one instead, these are a collection of use cases where Python is required, and each one of them have a specific library. So the first one is basically creating API. When you have a cloud, I think the biggest use case you can do is actually using creating the API, because especially in startups, when startup create a software or basically create their own web application, they have to communicate with the cloud. They have to take information, and to make it simpler, basically they create those APIs. As well, if they want to they want to have their own machine learning services, then they service those as an API. So that is incredibly, incredibly important. And then I will tell you in detail what it means, what is essentially an API, and how Python plays into that. The other thing you can do is creating your interface. And specifically with Python, there is a library called Gradio that allows to create your own machine learning and showcase it to client or to VCs. I think it's very important to know, because it's also a very, very quick library. You do not need a front end for that. And at the same time, but you need to host it somewhere, and you need to host it on the cloud. And the other thing is basically to schedule your own algorithm, because essentially another, when startups usually, when they have a series of action they have to perform, and some of them is data collection. And data collection happens on a regular basis, and you need automatic algorithms to be scheduled. So the first thing, I think this is probably one of the main cloud concepts that you're going to study, but I'm going to give you an introduction here, and then I'm going to show you how it plays out with Python. It's essentially the API. And the API is explained, I think, terribly, but the way I explain it is basically it's a gate to your own infrastructure. So you basically give some code to the client. The client can be usually a programmer, because he has to program, he has to use the API with code. You give the client access to a part of your infrastructure. So for example, he wants to access your database. Well, okay, then you give him the API to have access to that specific part of database. Or he wants to activate a resource like a machine learning algorithm. Use the API to give him access to that machine learning algorithm. And basically is nothing but a code that is linked to a URL. So you give the URL, this API, and then the client uses basically calls, is called the URL, and then you can activate the resource. That's what an API is, a simple gate. Now, where does it comes into play with Python? Because Python is also used to create APIs. So you either use something like you can either use plainly AWS, and what I mean plainly is like you can use the services that are already in AWS and do not require extra deployment, which are called Lambda and API Gateway. With the Lambda, basically it's very lightweight. So the cache does not allow for more than 50 megabytes. It supports every language. But basically with Python, you can just simply say, okay, basically you can use bottletree there. You retrieve data from a database, do a simple calculation. If something is simple, does not require libraries, you can use that. And it's used for very quick interactions. So you can retrieve data from a database, make a simple calculation, or even activate a process. And then you put it with another, in combination with another service called API Gateway, and that allows to create the API. So the API is basically managed by Lambda, and the endpoint, so the URL, is managed by API Gateway. Now, the issue with using Lambda is that sometimes you need to basically create machine learning software. And what it means, let's say you have a machine learning that or your own code that basically translates or like sentiment analysis. Very simple in reality. There are software that can replace that. But imagine you have your own algorithm made with sklearn with Python. You cannot run it in Lambda for the simple reason because it's too heavy. You cannot even load a library. If you have your own code in pandas that rearrange something that is so a good solution is a library called FastAPI, which is very, very famous. It's becoming widespread right now because it allows you to create your own API. So instead of having this paradigm, you use another approach, which is you create everything on your own. So you define the code. It says, okay, open this endpoint. When the user sends a request, so activates the API, then you can directly send him back like any piece of code you want, any piece of calculation. And this allows for maximum flexibility. So you can use libraries, and is used for making endpoints, so machine learning endpoints, long calculation, and basically to write custom code. Now, the issue with this approach is that you need to know how to deploy it. That's the difficult part, because you have to either deploy on a virtual machine or you have to deploy it in a container, and both are quite difficult to do. But if you know how to do it, then you can put it online. The second library that we can talk about is called Gradio. And Gradio is, sorry, I have only one example, but it's absolutely great. It's a library that basically allows machine learning engineers or Python backend to basically create any kind of interface just in Python, without any knowledge of JavaScript, any front end. Because the issue is, if you want to focus on the front end, right now everything has become very, very advanced, everything complicated. Not only in terms of graphics, but also in terms of development. Because, for example, to create something like this, if you had to use front end and the front end technology, you would ideally use JavaScript. But not only, you would need to deploy it, so you would need Amplify to deploy that. You need a secure connection, etc., etc. And that takes so much time to integrate. With Python instead, you can create an interface, and right now, for example, you can even create chatbots. So you can have your own version of large language model. You can connect to GPT-4, for example. This bot exchange that I did it asking GPT to simulate Galadriel. It was a joke for a friend. And you can see here it's my own endpoint. I put in my own link, and then I present it to a client, to my friend. And at the same, you can actually interact, use any kind of button you want in Gradio. and then you can deploy it. There is still the issue that you need still the deployment is the difficult part, because you either need a virtual machine or containerize it, but it's something that is possible. So that's the second library. And the other thing you can do is basically run a scheduled algorithm that will require something called, ideally, Docker. So there are cloud services like EventBridge that allow you to run something for every once in a while. So, for example, you have an algorithm, and you can run the algorithm every once a day. I have a company, for example, that is asking me to create an algorithm that collects the data of government data and basically rearranges it in a map. This is done every night at 8 p.m. So what I did, I create an algorithm, I containerize it, or I could also put this in an old architecture. I could put in a virtual machine, but essentially containerize it, and I run something called lambda container. And so lambda, but attach this code, and then I ask the AWS to run this code essentially once in a while. Then I take the basically, and then I can do everything with it. For example, I take the data. Once the data has been collected, I put in a storage, and then I allow the user basically to have access to the storage, or basically I can put in a map. So that's Docker is the other. I will not get into detail because it's quite complicated. It's impossible to talk. It will require hours to talk about Docker. But that's the most another advanced use case you can do of Python. And I think those three that I just mentioned, these are the initial use case you can have, and this will take about 8 months to 1 year to familiarize. You can do it in a few days, but then the 90% of the requests are going to be related to this. Because when a client, when somebody asks you to write some code, is mostly for those applications, or sometimes storage. There are other things you can do, but mostly is because they need an API. They need what is called deployment. Deployment is the difficult part. Is why the cloud essentially exists. And sorry, I left the title here, but basically, I would suggest these are a roadmap, a cloud. This is a cloud roadmap that I would suggest everyone. So the first, you can learn how to use lambdas, because lambdas are very lightweight, and this is something you can do without any deployment. You use two services, Lambda and API Gateway, and you can start writing your own lightweight code. That's how I started. So Lambda is a very good point to start learning, especially AWS. Later on, after functions, Lambda are called functions, you can study basically EC2, virtual machines. And virtual machines are a very, very technical, they're very, basically they are simulated computer. Most of the times they can be Windows, but most of the times they're Linux to run code. And so what you have to learn is to activate this computer, which is very easy, and they're very cheap. They can run at 14 cents a day. So it's totally affordable. So you can run this virtual machine, and then you can even use VS Code to enter the virtual machine and run some code. A good example, for example, could be a Discord bot. You need to run it somewhere, so you run it in a virtual machine. But to get comfortable with virtual machine takes about other 4 months. So in the first 6 months of your roadmap, you can start learning EC2. The reason why it takes so long is because the cloud is very unpredictable to learn. And so nothing works as intended. Most of the times the server do not run correctly. You click on something does not happen. You have to log in, but there is a problem. And so at the beginning it's very frustrating, but then when you understand how to handle the majority of the problems that are thrown to you by the cloud, then you can ideally you can get better and better. And so EC2, it's people do not use plain virtual machine anymore. They use more complex technology. But at the beginning, to run simple algorithms, especially on a 24-hour basis, is very good to understand. Plus, there is also a problem that if you choose a virtual machine, it might break without any consequences. But for example, if you exceed the amount of RAM, then it might, the virtual machines might break down, and then you left hanging. It's like, what happened? That is a very common problem, and but that's how you learn essentially the cloud, iteration by iteration, because it's much more difficult than Python. Then after that, you can switch to container, because when you deploy something, you need to learn how to use to containerize it. So when you deploy application for a company, all companies have containerized, and you need to learn how to use Docker. But Docker require you need to understand not only Docker but also how virtual machine works, which is the previous step. So after that, for example, you can take your container, you can push it to the cloud in a repository called ACR, and then you can run it in ACS. And that is even more tedious because the majority of times it does not, at least AWS, it does not offer a console to showcase the problem. And so sometimes the code, like the container, doesn't run, disappears, and you're still left hanging. Okay, what's the problem right now? And but when you get acquainted with that, is much more, you can do more and more advanced stuff, because all the things I've shown you, including fast API, Gradio, I deployed using ACS or AKS sometimes with Kubernetes, but right now ACS, and that's a way faster way to do things. It allows me to make any deployment with just one button. I do not have to touch or enter virtual machine or anything else. Then after 10 months, perhaps if you need, you can start using load balancer. It's much more complicated because when you deploy those links, you also need a private connection. And the issue with a private connection is a hell to make. You need to make a ton of steps because AWS is, it is mostly for engineers. Is when you want to engineer things little by little, and so it does not have a lot of built-on solution like many other SaaS. Load balancer, it allows you basically to manage the traffic, but it's much more complicated to set up. But when you know load balancer, you can handle the traffic on multiple container, you can put multiple containers together. That is probably it's more on the expert side. And I wanted to end with this slide, with 37 minutes in presentation, so I think I finished a few minutes earlier, but then we can start with the questions. This is a simple exercise that you can try on your own. I had some interns last summer, and I make them do this simple exercise. So, for example, when I show you this interface, I created a Gradio, like a chatbot, and basically it's very simple. I use GPT-4 basically with my own instruction. And so instead of asking GPT-4 every single time, simulate your glider, giving context, I hide the context in the backend. And so you can have your own version of GPT-4, so to say. And the way this is done is very simple. You have to create an API, so a combination of the two services, which is called AWS Lambda and API Gateway. And inside the Lambda, you have to install requests and interact with GPT-4. And so every time the user asks a question, you pass it to GPT-4 and you ask, but at the same time, you tell GPT-4 what to do. So simulate to be like an English assistant or something like this. And every single time, basically, GPT-4 will follow your instructions. So what you're creating is your own API, but on top of it, you have GPT-4 technology. And I think that's a very simple, you do not need any kind of deployment, you do not need advanced code to do that, just a REST API with GPT. So I think it's a very good place to start if you want to start with a cloud project. So I think we can switch to the Q&A session. I hope I gave you insightful, I hope I gave you some insights on both Python and the beginning of the cloud. So does anybody have questions? Hayala.
Oh yeah. Can you hear me, Mike?
Yes.
All right. Okay. Thank you so much for very thorough explanation on introduction to Python programming and the cloud. Okay, so I don't know if you can see the questions directly from the chat, or if not, I can display it on the screen. So can you see the
Yes,
chat
please.
from there?
No, I, oh, it's comments. Yeah, okay. Yes, sorry about that because I was in a full screen, so I couldn't focus on the comments.
Okay, so they'll be dropping their questions on the chat, so you can take it from there.
Okay, what's the connection of or difference between Cloud API and server-side business logic API written off the cloud? So what do you mean? Sorry, server-side business logic APIs. Um, for what I understand from the question, like Cloud API, is essentially is a very broad term. Could be any API that is directed to your virtual private cloud. And server-side business logic API, I'm assuming uh, I say it's a layer on top of it. It's like when you have semantic layer in the database. So I'm assuming business logic APIs perhaps are a simplification of some data that's been aggregated and presented in a business-like form, which the end user can understand. I think that's the best way I can format this question without any other context. Oh, software and web development. So the software itself is general. The software itself is basically is the I would say is the code itself, which is not is intangible. Uh, Web development instead is the piece of software which uh, is limited, let's say, to the code that runs essentially on your browser. So when you open a web page, that is essentially web development. Software itself, however, is everything. It includes web development, but it also includes machine learning, includes backend, includes programming. It's a huge general term. That I am not sure because if you're all the another question we have in the chat, are we going to be taught all things? Well, I hope. I think in cloud computing. I think there are many different things. I think you will likely start with the basics rather than going on detail. I wanted to give you a general roadmap because perhaps you can have instruction on specifically not only what to learn, but also what to avoid learning. Because I would not advise a beginner to start learning, for example, containers. That's terrible. It's too complex. How would a novice know which server to use in AWS? Good question. So I would start like this. Start with simple database like S3, because S3 is like a hard drive, and DynamoDB, because those are the services and those are just storage, but you can have an idea of how database works essentially in storage, and that you can interact with them without even using code. Later on you can switch to lambdas, to functions. So basically my suggestion is when you are a novice in AWS, do not try to study multiple services. It's counterproductive because you increase the complexity a bit by bit. So mostly you learn by solving a problem. So the way I learn is I worked for several startups and I worked as a fractional CTO. So sometimes the startups was asking me, okay, I need to solve this problem. And I had to find the best service to solve that. For example, right now I'm following a startup that are using chatbots, and the chatbots I need text to speech, and there is a service for that which is called AWS Poly. So every problem that I have in front of me, usually I find the service which best suits it, and I think that's the best approach that you can use. How much Python do I need to be efficient in cloud engineering? Well, I would say quite much, because at one point you will need to manage, which is it's good. It's not advanced level Python. And what I mean by that, when you code on Python, the advanced level is usually means you have to create recursive functions, complex functions that have a lot of variables that make a lot of transformation. In cloud, there isn't necessary that requirement. So mostly there are snippets that you can find even on ChatGPT or online that you need to run, but you need to run them properly. So you need to know Python in a very good way, but do not expect to run very complicated algorithms. The issue mostly with Boto3, which is there are the architecture on which is based quite old. So there are some concepts sometimes. For example, Textract, which is it's an AWS service to extract or to make perform OCR. When you perform OCR on multiple pages, it's kind of hellish to understand the code if you're a beginner. So progressively, yes, but it requires a lot of code if you want to do things in a very professional way. How to say so most, but of course, the labs, as I said, the library that controls everything is Boto3. So I think it's a quite relaxing, rather than having different libraries scattered. I think it's a quite relaxing um, mm, journey from Python to cloud computing. Do you have any other specific question, perhaps on large language model that right now are taking the internet by storm? Hello? What is the best way to learn Python? Oh, it's very so. My suggestion is this: uh, I only use, for example, when I learn Python, I only use the free resources because everything can be learned from YouTube very easily. Because maybe 3 4 years ago there weren't some many resources. Right now, all the courses you find on YouTube are free. So if you go on YouTube and you find Python courses and you choose a playlist, then uh, you can essentially find the list of all the lessons, and then you choose which one to use. You do not need to specifically pay for every course. That's my suggestion. Does it apply to other cloud services providers like Azure? Absolutely, yes. Yeah, the only thing that differs is the name of the services. But what I said, Lambda, for example, is called, I think, functions on Azure. So all the services that I've been outlining, they have the equivalent on any other cloud, would it be Google Cloud Platform or Oracle Cloud Infrastructure. So if you learn things in one cloud, essentially you can apply the same principle. My suggestion, though, is only learn one cloud. Specifically, let me search for Python. I learn. One second. I'm searching for Python courses. I think I cannot playlist. I think the thing you can learn. I don't think I can find it, but I do not have the name. But if you type, for example, on YouTube, just Python course playlist, you find the first playlist, I think, is 145 videos. You do not need to watch them all. The first 30, 40 are fine. Any playlist is fine. Can you know only Python and still have a successful cloud computing career? You mean rather than other languages? I personally, I know some JavaScript, but so far I only had to use Python to use cloud, because with it, you can control basically everything. Of course, there are different use cases. So when you are in a startup, for example, of course you cannot replace a front-end engineer, but with the Python you can basically control all the cloud. Then of course there are use cases which are way more advanced. In those cases, perhaps multiple languages are required, but we are talking about high scalability. And 5 years of your career, Python, I think, is a standalone language for to controlling all the cloud. I think that's my opinion. And thank you also for the recommendation that has we've been seeing from Mr. Uchenna. Please finish what you were saying about only learn one cloud. Well, yes, because what happens with the cloud is like different languages. You will learn that if you specialize, let's say in AWS, you it will take a long time because of many factors. Number one, because the technology keeps changing, mostly the interface. So perhaps when you learn how to use, for example, lambdas, it doesn't take a few days. It takes months to actually familiarize with that. You familiarize with scalability, with all the option to put it online. And so, it takes months to specialize in just one service like the other. And so if you have to learn different cloud, imagine just studying the same service, but for all of them. It basically makes no sense, unless, of course, you are specifically a cloud engineer. But cloud engineer, mostly they have to take a lot of exams, one after the other, and they specialize in multiple clouds. In my case, for example, I need to use the cloud because I need to tell startups or companies how to deploy, but I choose to specialize in one because I know I want to know everything there is to know about the things I study. So if I study, for example, on top of that even Azure or Google Cloud Platform, I have to study how they work, much more composition. I have to learn how to use their interface. It's too much work, but that is not the main problem. It's like, why would you want to learn multiple clouds? You only need to do one cloud to do everything. Exactly. Yeah, you either focus on one cloud, do not learn everything. I want. Okay. Yes, can someone please share the link also to the Python classes that you have recommended? I don't think I can. Let me see. No, I cannot join the chat here. And the reason why is because it's. I would suggest YouTube is because it's very simple. You can all the number one, the syntax is something which is very common. You do not find if you do a paid course specifically on Python, I would not know which advantages you would get. In a free course, you find all the resources. Essentially, because the syntax itself, so there are no secret to it. Is only you might only choose the ability of the teacher. That what basically counts. But on YouTube, they're very good teacher. I learned specifically from YouTube. I didn't buy any course. And it was 2-3 years ago. Right now, it's even easier because when you have a thing you don't understand, you can ask an LLM like ChatGPT to explain it to you. Is there a need for learning SQL? Eventually, yes. Not at the beginning, though. And SQL also is not considered a language. It is, but it's way simpler than, for example, Python. It's not. It would be probably complexity is like 10% of Python on the size because you do not import models. You barely have functions. So think of SQL as a mini language. Essentially, the reason why SQL it's important because part of the storage, uh, the majority of the database still use this SQL language because the relational database are still in use. Right now, you can even use NoSQL, which is basically DynamoDB. It's a version that uses Python dictionaries, you would say, JSON files. They're called differently in every language. But people still use SQL for aggregation or because it's very fast. So SQL is something that it will remain. But I would not advise people to start right now with SQL because, for example, personally, I only have to use it once in a while for a project. And so what it means is that when the startup basically is starting to store the data somewhere, then I need to create the design of the database, and I have to basically configure the SQL queries that allow the data to be stored correctly or to be retrieved. but it's not something that let's say it's intermediate. It's not something you would ideally do it as a beginner. You really have to find a reason to study SQL, I would say. SQL, however, is asked in many interviews because companies usually, they have, especially if you try to work in a big company, they have a lot of data. We are talking about terabytes, and basically they, to the people who work there, they ask to sometimes, especially engineer, to retrieve data in a particular way. But if you're working at startups, you basically have no need for a database, an SQL database, because no startups have any initial data. So it really depends. The more enterprise level you want to go, the more SQL essentially you need. Thank you, Zedek, and thank you for being here. Okay. Do we have any other question? I don't think we can hear you. Well, thank you so much. I think that will be all, unless you have other question or remarks. I think so. I think for what I've seen, is it possible for settle for Azure at the end of my initial training? I mean, definitely. I personally, for example, I studied the cloud without a lot of help, from mostly because I had to go from one job problem to the other one. So when I was going through my work, they were asking me to do things, and I had carte blanche on which one or which service to use. Is it possible for you to start actually with one cloud and choose another one and specialize in another one? Because I mean, even I thought, especially at the beginning, the principles that are taught on one cloud are valid for all the other. Now this changes when you go really in depth. What I mean by that, that's where the things get complicated, because if you specialize, let's say, in one service like lambda, and you study that for 1 month, and then you see that compared to another cloud, let's say Azure, there are not too many difference, but they're starting to be different. That where the issue of studying multiple clouds. But if you are at the beginning, I think that is totally okay. So I think it's 58. I think it will be. I think it's. I do not have any other thing to add. Well, I thank you so much for your time, and I hope you have a very relaxed and very insightful rest of the course on cloud engineering. Have a great day, everyone.